Hello everyone, welcome to the stream. Today we will continue work on the iCEBreaker Bitsy, just like we did in the last two episodes. I will show you what it is really quick before we start. So the iCEBreaker Bitsy is a small development board. This is the desktop here. So iCEBreaker is the ICE40 UP5K FPGA development board, and the Bitsy is a small form factor board that is essentially inspired from tiny FPGA as well as the Teensy, which is this board. So Teensy is a really nice ARM-based board that is also derived from previous Arduino boards. So this has a long history, and I know Paul, I know these boards, and I find them very nice, and I find them very good for development on breadboards, and there's a bunch of shields for them. So I wanted to make a smaller version because I was also making my own with an ARM Cortex on there, or STM32 F4 instead of the, Fairchild, right? These are the parts that are on the Teensy, essentially as a demo board for the Blackmagic probe, because most of the small dev boards don't break out the JTAG connector. So I made my own as a demo, but by now there's more boards that come with the JTAG connector, fortunately, so you can debug it with a proper debugger and not rely on the stripped down debuggers that are built into the development boards. So from that history, I also made the iCEBreaker Bitsy, which is just the ICE40 UP5K that is implementing the USB interface directly in the FPGA instead of using an external chip like on the full-size iCEBreaker, which is done with the FTDI chip. And this also gives a little bit more flexibility for tools like CircuitPython. So when we go and want to use CircuitPython, it requires that there's a USB interface, and we need to have more flexibility than the FTDI chip would provide, because we need to be able to provide a mass storage type of USB interface for dropping in the binaries and whatnot. So because of that, the main reason was that we are now only coming back to the Bitsys is because I was using Luke Valentis from the Tiny FPGA bootloader that had trouble running on the UP5K, which is a little bit slower FPGA type. And since then, over the last year, thanks to the FOMU, this bootloader got majorly improved, as well as a lot of work from Sylvain Manau too, and Sean Cross, and a lot of other people. Now we have a working bootloader for that can implement USB properly. And Sylvain actually made this green board, which is the second revision, which has a few bugs fixed. And we have a few more ideas that we were working on in the last two streams. So let's look at the to-do list, what we accomplished and what we will be doing today. So this is the, that is small. I should have fixed that. Forgot. Let me change this really quick. Is that better? This should be better readable. Yeah, this is much bigger. I hope this is readable. I'm still not sure if this is big enough for cell phone views, but yeah. Anyways, the lines are already long enough. Anyways, so we had to do a bunch of circuit changes. We had to update the button, which is still an old one that is still derived from the Teensys. We have better buttons, the white ones, which are nicer and more tactile. We had to fix the CDAN indicator. We had to change some jumpers. We added an RGB LED to the mix. We added a footprint for PSRAM on the back. Oh, it's readable. Thank you, Matt. That's good. Thank you for the info. That's good to know. And we had to fix the VPP2 V5 circuit and do some modeling. And the last thing we did on the last stream is replace the MEMS oscillator. So we were choosing something that is more common, easier to get, and has more different vendors as well as manufacturers of the part available. And we will do one more small thing related to that before we plunge into routing, which will be interesting. I'm really curious how well that will go, because this is a fairly small board, so routing will be a little bit challenging. It's not, of course, it's not some multi-layer BGA board, so it's not super high level and super hard, but I think it will be still an interesting challenge to work on. Yeah, so as this is a stream, feel free to ask questions in the chat. I'm happy to go on tangents. Don't worry about this. It's all just at the end for your entertainment. And if you want to ask something regarding the work we are doing here, please feel free. I am happy to repeat myself. It's not a big deal. It's a stream after all, right? Okay, so as you see, we did some changes here. We fixed the oscillator last time. That was, I think, the stream on Sunday. And one thing that I was checking is what different footprints those oscillators provide. And the oscillator we were looking at, so this footprint is actually, if we go and change footprint, you can see that this is an Abracon Esden-Tempski footprint. So it is possible to get those on DigiKey, and they are designated as 2.5 by 2 millimeter, which is good because those parts are also available from different vendors. So let's look at that really quick. So this is the ASDM part, and here is the recommended footprint, which essentially the important thing is the pads are meant to go outside to the side of the board because the metallization on the package is protruding a little bit to the side. I think this is where the saw is cutting apart those, because I think these are done in a big slab essentially and then sawn apart. And that's how the lead frame stuff is being done for this kind of part. Arishab, thank you for following. Welcome to the stream. And but then I was also looking for an alternative part that I can get from LCSC, hopefully for a lower cost. So if we look at Abracon at 1,000 units, they cost about $1.15 on DigiKey. DigiKey is relatively expensive usually especially when you buy in bulk. But it still gives us a little bit of a feel where this stuff is standing. And I didn't do arrow quoting and whatever to get the most optimal price for the ASDM parts, because we can just go on, let's see, on LCSC, and these parts here are a little bit more affordable. So this is a alternative part that should do the jobs. This is 1.8 volt. Wait a second. I did find a 3.3 volt version. This is something you have to be careful with these oscillators. Which voltage? Yeah, there we go. So this is the 3.3 volt, and there's another 3.3 volt. So in any case, these cost about 1/3, even in single units, of the 1,000 pricing on DigiKey for the Abracon part. So these are pretty decent solutions, and And it makes it easier because you don't have to go through the quoting process and then lead time of 6-8 weeks from if you even buy them in quantity at full reel. Yeah, the Octopart pricing, it's, yeah, sure, we could look on there, and I think I even did. So we can just, for the fun of it, we can just plop this into Octopart. Come on, am I in the wrong window focused? Yeah, Octopart. It doesn't matter, I'm pretty sure they are still way more expensive than the LCSC pricing. Let's see. Yeah, Abracon. Yeah, so in the best case scenario on Octopart, if you don't get special pricing, which is possible to get, but yeah, you can get, when you buy like 25,000 of them, you can get 60 cents per unit. So I don't think we will be buying that many. But it's good to have a comparison. Same series package. That's a very good question, Sylvain. Let's look. Let's look if there is also a higher frequency version. So let's reset this and see how high it goes. 24 megahertz, and yeah, I think that's it, isn't it? What is the series name here? Do they have a series name? S2D12. S2D24. Yeah, so yeah, we can get a 24 megahertz version of, or 48 you said, sorry. 48, 30, 48, there we go. Yeah, we can get a 48 megahertz version of those. So yeah, we could go up. I assume, Sylvain, you are to make the USB stuff easier, to just have a direct clock that we need to clock the USB interface. That's what you are talking about. All right, so let's see. T-Zark picked up a similar microscope to yours a couple of weeks ago. It's so much easier to solder now. Yeah. A microscope is pretty essential in my opinion. There's a lot of people that are doing electronics, hobby electronics, and they don't have microscopes. I always recommend just get a microscope. Some type of a microscope will make your life quickly easier. Kaanchi, Kiran, thank you for your follow. Welcome to the stream. Yeah. So PLL something, oh yeah, so directly drive the 48 megahertz and not have to use the PLL for the USB stuff. Yeah, that's a good idea. We should explore those, and maybe it makes sense for the Bitsys to actually by default use a different clock or a different oscillator from the get-go. So that might be a good idea to actually go with the 48 megahertz and make the Bitsys their own thing because of the USB interface. So yeah, that's something to think about. I'm not opposed to it. So the reason why we are looking at the footprints and these parts is because the footprint for this part is slightly different because the packaging type is also different. It is not this slab of plastic, but it is this ceramic packaging with a metal lid soldered on top to put all the electronics inside. It would be actually very interesting to take one of those, pop off the lid and look under the microscope what is inside, if we can see something cool. So as soon as I get some of those parts in my next LCSC shipment, then we can take a look together inside those packages. Yeah, so we need to adjust the footprint because I assume we might use the ASDM parts from Abracon as a reference, maybe as for prototyping a little bit if we need them fast, but they will unlikely be the core part that we will be doing production with. So it is better to optimize the board for this part. And I already checked, and this footprint will work for the Abracon part. It's not that far off, but it's still different enough. So we should definitely adjust it. And that said, I can either edit it inside the PCB, do just edit footprint, and when I save this out of here, then it will just be saved in my PCB, and it might get lost if I do some updating. So I think a better solution is actually to copy that part into my own library really quick. ABSM? No, I keep forgetting what the stupid acronym is. ASDM, there we go. So this part, and file save as, and we can choose my PKL library, PKL MISC, MS, Murata, pads. Do we have it in oscillators, or do I have a group for this? Allegro, no. I don't think I have a dedicated oscillator library at the moment, so I will just put it in MISC for now. That's fine. And then we can rename this. SMD, and this is not Abracon. Let's see what the naming is. Yangzheng Tech. Let's call it this. Yangzheng, and then this should be S, not OP. Oh, it is different family, I guess. The 48 megahertz. This is OP2520. It's not that very many of them there. There's more of the Seiko part in there. Oh, come on. You can't go back here. SMD 2520, 4-pin. These are the two types we need. Let's still go with the 12 megahertz. This is what we were doing. Don't think it has a proper naming in here, does it? SCTF? SCTF product. Okay, so this is SCTF then. Yeah, we might need to do some adjustment later. 4-pin. Just... Is good enough? Let's see. SCTF, yeah, Shenzhen SCTF LEC. Yeah, we would need to check if. So what we can also do, if we don't see the exact part available here through LCSC, I can ask LCSC to look if the vendor has also a 48 megahertz part specifically. They do quote stuff for people. It's like, you see my hands here. Let's do this. There we go. That should be better. A little bit color. All right. So yeah, I think so. This is SCTF, and then S2DXX should be the naming, I guess. So it's close enough, I guess. S2DXX footprint. Okay. Okay. Did I miss something? Ah, yeah. This is the correct name in here, otherwise it doesn't change. That should change it. Come on. Still doesn't change it here. SCTF, SCTF. Huh. Oh. Save changes to library. I think then it should, yeah, there we go. Okay, I saved it and then it renamed it here. That's good. And now we can edit this. And the changes are, this is 1 by 090. Is 1 and 0.9. Okay, and then right click, pads, copy pad properties. Oh, come on. Pads, paste pad properties, adjusted, good. Now we can change the positions. It should be 1.3 by 1.7, so x is 1.7. 1.7 divided by 2. And what was it? 1.3? What did I say? Yeah, 1.3. 1.3 divided by 2. So it will not protrude as much out from the board, but that should be fine, I think. We shouldn't have a problem with that. What? Oval? That's not... We should also make them rounded rectangles as per usual. 25% is good. $65. And this is 65. Oh yeah, rounded rectangle. This is the standard rounding, the 25% or the minimum. So it does it automatically. $6.5. Did I already? Yeah, I already adjusted this one. What's going on? Number 3. There we go. Oh yeah, the rounded rectangle, of course. Okay, there we go. Why the rounding? So there is, JDEC is recommending to do rounded rectangles. That's first of all. So this is an industry recommendation by now. First, I think there are several reasons. One is etching in PCBs. You can get more around. Also, it's pretty. It's pretty. And also the chamfering of the solder when you solder a reflow board, how the solder is. The surface tension is around it. It's like nature is never square, so it's like you force the solder to suck in from those sharp corners. So it is you get better filleting. That's essentially what it is, and more reliable, better filleting is a good thing. So that's why you want rounded rectangles. You might need to tweak it, especially in cases like this, to make the rounded rectangle a little bit less harsh. So I did have to adjust it in a few places. Check the pin numbering. Welcome, George, to the stream. And yes, you are correct, sir. I should definitely check the pin numbering. So this is, I'm pretty sure, from the bottom view. I hate that they do this. It's really confusing. Nature hates square, yes. That's true. Anyway, so 1, 2, 3, and 4 from the top. So that should be good. 1, 2, 3, 4. And then we should also check that our symbol is also correct, just to make sure. And the symbol is 1 is enable, 2 is ground. Oh, come on. 1 is enable. Where do we have that? 1 is tree state. See notes. Connected to ground, stop working. Product is working properly. What? Pin 1 connected to VDD is floating. The product is working properly. Connected to ground stops working. That's great. Oh, I love that. Okay, so that's the tree state. We don't really need to connect to it, I guess. So 1 is an on-off. So it is basically just a pull down. So we don't really need to have anything. But I want to be compatible with the... so I will leave that pull-up resistor here. Because the Abracon part is the same pinout, which is 1 is also standby. Which means... Oh god, is it reverse? Will it be reverse? What does it say? It doesn't even explain what this standby means. Great, thanks Abracon. Is there another explanation somewhere? Come on. Unprogrammed. So I assume high is standby and low is ground? Ugh. Yeah, you're right. You're right. Standby doesn't mean anything. Like, how do I, now I have to imagine what they mean. I assume when it is high, it is standby, meaning it is reverse to what we need here. So we need to pull it to ground to use the Abracon part. Oh man. Do I need to add a jumper selection here? I don't feel like doing that at the moment. That's stupid. Yeah, let's just stay with the Chinese part for now. God damn it. Yeah, let's leave this to ground. We can always rework it with some wires and make another revision later. We need to test it anyways. It's fine. So pin 1, 2 is ground, yes. 3 is output and 4 is VDD. That's fine. Okay, so at least that part is right. Oh man. Thanks, Abracon. Yeah, I will probably have to look in some more global datasheet or something. If it is high, it is operating normally. Okay. Yeah. Supply current. I assume it is tri-state function standby, high or open oscillation, 0, high Z. Okay, so yeah. So it is described here. That's good. So there is a description in here. Good. Yeah. All right. Okay. So we are good. Thanks, Greg. Okay. So yeah, that should be fine. Now we can. Actually, we have to change this here. We do this. Let's pull it out of my library instead. PKL MISC and oscillator Esden there. Okay. Did I save it actually? Yes, now it's saved because I have the feeling it didn't update here. Let's do this. Yep, that looks correct now. And now F8. Wow, come on. I'm trying to press F8 here. keep existing associations. I think I need to change footprint to footprint. There we go. So that looks good. I might want to name that net. I'm sorry. That was loud. I'm sorry about that. Should have muted the microphone. It's the dryer. Don't worry about it. It's not, I don't think I'm getting... All right. So that's done. So we updated this. We can save this. Let's see what we should work on. Yeah, so we did match this, so we can make it as done. Now we can look at routing the flash PS RAM. I feel we should remove all the routing that is in the way and put the parts in places that we roughly want them in the future, so that we have a little bit better feeling of what's going on. And I have to close the window. It's getting cold in here. Thank you. Yeah, I'm trying to have at least good reflexes here. Not coughing in my hand or something. Yeah, good. The silkscreen stuff is pretty irrelevant at the moment, so we can at least move this stuff out of the way. Oh, come on. Yeah, I should use Shift here. Select those. We will be able to place this back in later. And yeah, I am still not sure what I want to do with the RGB LED, because the RGB pins are here on top. We have the 2 voltage regulators, which we could replace with the smaller regulators that are also on the Glasgow, because it uses the same voltages, also 1.2 and 3.3 volts. So we could save some space here by using smaller voltage regulators. That could be another yak to shave here. Yeah, I'm not sure I want to do that at the moment though. And then we have the RGB LED, and we have 2 possible places. We can put it here next to the connector. So let's look at that in the 3D view. Although we could maybe squeeze it in here, the RGB LED that is closer to these guys. Another option would be to scoot this stuff a little bit further down to the USB connector and move this fella up here and make these move also in this direction further. That would, because these are the RGB. Oh, we need to go to the bottom of the board anyways because of the jumpers. Because we want to be able to disconnect the RGB LED if we want to use these pins for something else, and the LED would interfere with that. So we have these jumpers here in the left lower corner that we want to put on the bottom of the board. Yeah, let me still ponder that a little bit longer. In the meantime, let's clean this up. I think we can clean this up. Delete. Oh, this is a locked item. Yeah, let's leave it as locked. We don't want to probably go all the way there. Let's just do this junction. So there is a difference between if you hover over something and press U, then you will select just this segment, so from a pad to a pad. And if you press I, then you will select the complete net of the wire. So that's the difference there, I versus U. So we should probably just delete this to clean this up, to make space, and we should move this stuff over. Not like this. We should be in this mode and grab it like this so that, oh, come on. Nope. It's probably easier to just delete this like that. Yeah, I think we will have to go above it anyways. Why are the flash chips so huge? Well, because this is the standard packaging for flash chips. SO8 is the most common package that flash chips come in, as well as PS RAM chips. So this is, if you have a flash chip or a RAM chip that has flash cells are big. Yeah, so that is also a fair explanation. So all the packages, if you look at this, of flash chips, this is quite a chunky silicon every time. That's why you can't put them physically in some smaller packaging in most cases. So in theory, you could have something that is more stacked. So you have like a thick package and you have multiple dies that are, I've seen, if you look at x-rays of some of the flash or memory chips, they even have multiple dies that are staggered on like a ladder and then connected together. Yeah, NOR flash, yeah. It's pretty big. Yeah, and this is why you either have like a BGA thing in like a pretty big slab, or you have SO8, which is pretty common in the lower memory ranges and serial flashes and RAMs. So yeah. Let's do this. Let's move this. Why is it? Oh, I keep pressing the wrong button here. Let's make more space. This is probably not really necessary at the moment. We should move this out of the way and move this in place. I really don't like these. How do we do this? One of these is just, this is a library convention thing. I don't like this. I don't put designators on silkscreen anyways, so we can just move it on FFab and then we are done. Save. Better. There we go. So that should do this. Page up. We will have to think about the reset or the chip select, how that is wired, because I think for the direct SRAM programming we have to disconnect. How does this work? We just want to disconnect the flash chip, right? Yeah, it's stacked for higher density. Yeah, 64 megabits for DRAM is not that big. So in theory we could, oh, let's see what packages we have available for these flashes. There are smaller ones, especially from, so I did find for the flash a smaller packaging for a different project, and these were former Atmel packages, and then I tried to use them and actually found a bug in their state machine inside for the SPI interface because we were reading too many of the bytes after the JDAC factory settings, and if you read too many bytes, then you lock up the complete flash chip state machine. So, well done, Atmel. So yeah, that was a fun fact. But yeah, there are smaller packages maybe. But I would like to keep, especially this board, as close as possible to an existing iCEBreaker, which uses the bigger part, because then I can use the same parts on multiple boards. That is always a good idea. You can buy more of the same part and increase your volume. So having distinct parts, we are already doing the oscillator part, but the oscillator will flow back into the main iCEBreaker. So because I need a part that is more common on the big iCEBreaker anyways. So that will flow back. Same thing if we decide to change the voltage regulators. This is something I'm using on the Glasgow. So that will be consolidated there. And if these regulators turn out to be a good solution and I can get them fairly easily, then they will start spreading to other boards that I make anyway. So we will consolidate that stuff and also increase the volume of the particular part used. So there's more to the consideration which parts you are using beyond just, oh, the specific application and the specific board you're making, especially if you try to, yeah. And you can keep them, yeah, reels, not only on the machine, you can also keep them in the feeders. So refeeding the feeders ends up being the most time-consuming part currently when I load the machine, because my really old machines, the feeders are not very ergonomic to load and unload. Much more modern, just more modern as in like 20 years old, not 30 years old machines. They are much easier to load. So yeah. Yeah. Yeah, why are you not comfortable with that, George? I'm very comfortable with them. They feel very cozy. Yeah, they are very close together. It's like there's not much webbing. Yeah, whatever. That's PCB manufacturer's problem. Yeah. So there is a Barlow lens underneath to get the working distance, and that's the really the only stack up on the microscope. So we have the eyepieces, they are 10x eyepieces. Then I have a 0.7 to 4.5x in the body, continuous. Then 0.5x Barlow lens to increase the working distance by 2, because otherwise you get a much smaller working distance. And then on the back here, there's a bellow to do focus adjustment for the camera. an adapter, a 0.5x lens for the camera itself, and then HDMI camera that goes over a HDMI to USB capture into the computer. So that's the setup there. Yeah, 0.7, it's awfully close. I think you might have like higher magnification microscope in general. Maybe that's the problem. Yeah, 0.7, what would it be? So this would be like 1x, and 0.7 will just increase it a little bit. So it's always good to, yeah, the 0.5 gives you a reasonable work distance. And still, I managed from time to time to touch with the soldering iron to the cover around the microscope, and then still melt it a little bit. So yeah. Yeah, so the drill hits. Yeah, I probably should actually listen to George and make them further apart. The wall thickness here is pretty small, so that the PCB manufacturer might not like me. Yeah, let's just delete that, it's fine. Yeah, I'm not that concerned with this kind of stuff. It's the PCB manufacturers that I went with so far. This is the problem with a lot of the design for manufacturer stuff, especially when you send it out for an SCM. They so rarely, yeah, it will be a plated slot at the end if they break through, and they are all the same, so it should be fine, really. Just increases the amount of copper connecting the two layers together, I guess. And it will be, if they break through, it will be less of the copper surface in the vias. So yeah, yeah. So going back to my rant here. So the problem is with a lot of the design for manufacturer stuff, the assemblers as well as PCB manufacturers, they rarely actually tell you if there's something slightly off. Like, for example, the drill hits. I've never had anyone complain about this. If that was an issue, why aren't they not complaining about this? It's always like pulling, I don't know what, like something out of tar to actually hear from the PCB manufacturers and assemblers what the actual issues are. Only when you start doing it yourself, like I have a pick and place machine, I assemble stuff. I learned a huge amount of do's and don'ts because I run into the issues myself, and I'm like, yeah, you can work around it, but it is making everything so much more tedious. I doubt it. I think the plating will be fine in these 3 vias. Yeah, no, I think it will be fine, George. It's like, this is really going nitty gritty here, which I understand where you are coming from, but seriously, I don't think this is that big of a deal in this case. And yeah, that's what I said. That said, it's like pulling it out of people is really hard, and it's like that's the fair part about what George is saying. It's like he audited a lot of boards, so he has recommendations, and that's why he's saying I shouldn't be doing this. Sure, fair enough. Depends on what is your PCB manufacturers, what are their tolerances, what is their plating issues. Especially cheap Chinese PCB manufacturers, they don't do visual inspection very often, and or automatic inspection of the PCB. So do you know what the plating is? I have seen at completely non-problematic boards that have are really boring. One would assume, and then you get them back and the plating is all wonky and weird, or the gold plating is not on there. You see that they were obviously dirty, not cleaned properly, and what you complain to the Chinese manufacturer, they just will refund you, and it's like, or not even that. They don't care. It's like the reliability of the boards is not that relevant, and refunding 1% of the boards because someone complained is still not worth them to make higher quality boards. That's essentially the take here. Yeah, I think I should be nice here to the PCB manufacturer. So at least what we should do is, come on, at least move them so that we don't have them stacked on top of each other as hard. There we go. Something like that, I would say. Is that better, George? Oh yeah, I have 2 boards manufactured. Yeah. Let's see. You can only see it from the back here, I guess. I still have to figure out where we are looking at. Yeah, that's the point here. Yeah, so they are broken through. It becomes essentially a slot. Yeah, so this one is a slot. Yeah, it's just a power layer connection. Why cluster in a row? There's no reason. It's like I just wanted more 3v3 connections from. No, I'm not trying to make a slot. I'm just trying to connect the 3.3 volts to the ground, to the power plane, to the internal power plane. That's all I'm trying to do. So let's see how Oshpark does it. Yeah, the massive amounts of current. Yeah, totally. Let's see. Where are we? Where are we? Oh, we are on the wrong side here. There we go. So that's Oshpark for you. Oshpark has a little bit more of webbing there. So yeah, that's the comparison. I'm not sure, Sylvain, where you got the green LED from though. Yeah, I could probably just remove that 3.3 volt via here. That's it. I see it is very, very controversial. So let's just do this. Should make everyone happy. Yeah. So you see what you guys did. So this is Oshpark. So the fab decided to not make it into a slot. They just made webbing between them. So yeah, so let's go back to the here. Okay, I removed that additional via. Now we have just 2 far away from each other, so we should be good now. Okay, alrighty. So let's do some more, because we are now way ahead of where we should be. We are totally putting a cart in front of the horse here. We should actually get the routing first ready, and then we can do the minute polishing later, I think. So let's get some routing done. I can delete those ground ones. I don't think we need those for now. Can make those connections later. Yeah, So what is this? I don't remember. So this is the VPP 2.5. So that's what I did here. Should move it out of the way too. There's so much. I'm still annoyed that these jumpers are pretty big. It's like 0603 size jumpers, and I'm annoyed that they're too big. Okay, so let's also put these jumpers here in and clean this stuff up. So clock. And the 3.3 volt could be probably connected directly there. So this is the pull up. Yeah, you need that. Sylvain is impatient. He needs to keep going on his FPGA development. I know. Sorry, Sylvain. Complain to the others in the chat. We need to focus here. Let's keep going. This is also out of the way. Oh, the 3.3 volts here. Let's clean this up because this is just in the way for now. Yeah, I don't know what the situation will be like here when I put this guy back in. Oh my god, the naming is huge. Oh, yeah, we should also edit this. I don't like these guys. Let's get rid of it. Yeah, as you see, I never put naming on the. So all the designators, I pretty much never put the designators on my boards, because well, I tried to explain that earlier. I will show you in a second again. So you select, you can select either, so single segment you just click, then you can just select the track. Then if you want to select a segment, then that it goes from pad to pad, you press U. And if you want to select the whole signal trace, you press I. Then it will select everything. Does that make sense? So I is the whole signal, U is the segment from pad to pad, and a single segment is just a click. And the same thing if you just hover over the trace and then press delete, I think it deletes the whole segment just like you were using U. So yeah. So if you hover over it and don't select anything, you will delete the pad-to-pad segment. Okay, let's try to figure out what to do with these jumpers. I think we can still move and make more space here. So this is the LED, that's the chip select for the RAM. The naming here is very bad. So let's see what's going on here. Why don't we have net naming here? What happened? Ah, it's because it's behind jumpers. So flash SS should be this one. Flash SS, so that's that. Then we need S-clock should be named. So now if I press F8 and the window is update PCB, close, let's see. Yeah, that's flash SS. So we can just have this jumper here. We might, yeah, I don't really want to have the jumpers on the top of the board. Oh, Mike Welling. Welcome to the stream. Nice to see you here too. Whole crew seems to be coming in and out into the channel. It's nice. Should actually move this camera because it's dropping a shadow on me. So yeah, there we go. That's better. Yeah, so it is a mellow routing stream today. Let's make space here. This one is still, yeah, flash write protect is already, has a name. Then IC done goes through here, that makes sense. Flash is fine, so iCEBreaker, and the iCEBreaker goes also to this pad here. So that will be fun to route. Probably has to go on the top. Then we have one signal that still has to go around. And this is the 2.5 volt. Page down. Let's make some more space here. Oh, come on. Why are you being a jerk? There we go. Can we move this? Come on. Move! What is the constraint that you're complaining about, huh? Ah, come on. KiCad is sometimes being a little bit annoying, and I don't know why. Why are you being mean? Yeah, why can't I? Because it's probably colliding with this, and it doesn't show that. No, and I still can't move it. Okay. Yeah, it's stuck. Yeah, either my installation is really weird or something is, yeah. If I go here and then interactive router settings, not walk around, but highlight collisions, that should help, I think. Come on. And I can't even select anything. What's going on, guys? I want to drag this page down. Now I can. Yeah, somehow things become weird from time to time. And I cannot place it. Oh, yeah, there you go. Because in the right upper corner, this trace has a collision that was pre-existing. And because of that, the router doesn't allow me. But if I am in the normal interactive router settings in push walk around, and this collision is there for whichever reason, doesn't matter. There's an override modifier. I'm sure there's an override modifier. Probably Alt, I would assume. Alt, drag. I cannot select it. If it is colliding, then I cannot even select it to drag. Shift drag. I can't. Control drag. No, I can't. So there is probably some override, but it's not very obvious. And so regarding those overrides and regarding those key combinations, so what I was showing off a few times, this overlay selection where you can select footprints that are underneath, like for example in this situation. MS Vissa, thank you for following. Welcome to the stream. So I was showing off, like for example, I cannot select the footprint on the back of the board. So I did report this as a bug report on for KiCad, and then Seth Hillebrand, he replied to this, and the only response he had was essentially, oh, there's an override for it, first of all. So there is an alt override for it, as well as he cannot reproduce it. So I don't know what combinations of operations, because to be fair, if I restart KiCad here, so let's do this. So when I save this, and I probably restart this, let's see, then it probably will be behaving correctly again, because it worked fine when I tried to reproduce it. Yeah, it doesn't. The only way of doing this is me going between these two. But there's obviously these two footprints that are available for selection. And I have to use the override. So that said, okay, fine, maybe we can live with this, having the override. The problem is, it is not discoverable. Alt is not discoverable. And then Seth's reply to this was, oh, this is just a failure of the documentation, that it is not written in the written file documentation that comes with KiCad. I didn't respond to this yet, but I probably should. And my view on this is the following. Documentation, no one reads the documentation and no one ever will. So if you want a UI that is intuitively easy to use, you have to find a way that these things are discoverable without reading the documentation, especially for those that are using this software on a regular basis. I somehow feel I am already know about KiCad quite a lot because I read the mailing list, because I follow the pull requests and bug reports on KiCad. So I find these issues, and expecting people to read the documentation, it's like we all know people don't read documentation. People only will get frustrated with KiCad and basically throw the towel and move on to some other software that is more intuitive to use. So improving the documentation is important, sure. It should be in there, but you have to find a way so that it is easy to discover without reading the documentation. For example, if you try to click several times on the same thing, it should have a pop-up that says, it's like, do you want an override? Or just disable the heuristics. I understand the heuristics are fun and nice and make things easier to use if it works. But in situations like this, it obviously doesn't work right, and you need to use an override to make it work for you. So All right. So Altium's menus work. Almost every action has a keyboard character letter assigned to it, and that's a single character is underlined in the menu item for the action. So within the design menu, D is underlined. There is a netlist section, N is underlined. Self-documenting software for the win. Yes, exactly. So not only self-documenting, but also easy to discover. It really good UI design is, and we learned a lot about intuitive UI design. We do expect that software is much more intuitive these days. Yeah, some mouse controls. So what I was thinking is have some kind of annotations next to the mouse cursor like you have in Photoshop or some other graphical software. I don't know, have at least some tooltips underneath in the window that explain things and say it's like, or give recommendations what you could do. Yeah, well, it's so making the argument now, like, don't take me wrong. It's like, I will not recommend that you use Eagle. That's definitely not the case, and I will definitely not do that because KiCad is definitely moving in a right direction in general. And I'm a huge fan of KiCad and the team that works on this. So I'm not a huge Eagle fan, and I will not endorse that software because it's closed source, it is a rented software, it is another corporation just gobbling up users. I will not recommend you use Eagle, for sure. I still think you should use KiCad. All I'm saying here is constructive criticism, what we can improve on KiCad. And I know for a fact that the developers of KiCad do listen to this input. And they really are doing their best, and they do improve the software massive amounts over the last 2-3 years. So I rather rent KiCad. I pay what I would pay for Eagle to CERN every year. And this is what you should do too, because the software is moving forward much better. And I think and I think this is where we all as a community should be pushing forward to and push into. This software is a community effort. We all are in this together. It's not just the corporation customer relationship we have here. And this is the nice part about this. And seeing how far KiCad came over this just short few years, with the new team of developers, now not so new anymore, and how KiCad went from having no paid developers to 2 paid developers. Then the Wayne Stambaugh is now working full-time on this. Seth Hillebrand, I think, is also working full-time. They are now not only part of CERN, but also part of Linux Foundation. So you can donate the money, and as a as a company that is using it for professional work, thanks to Seth and the KiCad Foundation or something, I'm not sure what the exact name is, you can buy a support contract. So you can use it in corporate environments and have someone to fix things immediately if you need them to, just like for other commercial software. And by doing this, we all benefit. And even those that can't afford the software but want to learn and be better at PCB design, they can use the software without any financial barriers on this. So Eagle is not the solution here. KiCad is. But we need to make KiCad better. And all I'm saying here is, these are my observations, how I feel about it. I'm not blaming anyone. That's definitely not what I'm doing. I just think it would be better if it was a little bit more self-discoverable. That's all. And again, that said, the UI went strides over the last few years. There are people that are former Adobe employees who were in the UI design team that are working on KiCad and consolidating the items and improving the UI design. again, by strides. So we are moving in the right direction. It is awesome software. It's very exciting to be part of this community. So that's it. Sorry for this huge rant, but I do feel passionate about KiCad. I love this software and I love the community. We just have always something to improve. That's all. Yes, so Michael Welling, that's correct. And this is what it should be. And it usually does that. And this is what this bug report that I opened on KiCad is about. In theory, there should be a menu, or at least so in this case, for example, this is something that wasn't working correctly before. So currently, I can at least select these two. But after I do some modifications, this heuristic, which item I might mean, stops working. And I can, independent of where I click in this area, it will always select the jumper on the back. So there's something weird going on, which I don't know exactly what is going on, what it is, that after, so currently it does select correctly, I think, because the heuristic works right. But after, let's see, if I go to the other, let's go like this, back and forth. So this is still working. And then I go back here. So let's try to debug this a little bit, just a little bit. I'm sorry, we probably won't get too much routing today, but at least we can look at maybe this issue in KiCad. Maybe F8, so let's try, because who knows, maybe F8 is breaking something. And then close. This is still working. Is it? Yeah, it's still working here. This is working fine. And I also had issues, yeah, for example, here you get the disambiguation menu, which is fine for the text. I have situations where it always selects the text on the back and doesn't offer the menu at all. So I'm really curious what the combination of actions is that breaks the heuristic system. But it definitely happens here in stable release of KiCad as well as in nightly. I think in nightly it like immediately didn't work right on this board. But yeah, it's at the end, regarding, again, going back to that bug report, if Seth cannot reproduce this problem, he can't fix it. So eventually, I hope that over time, I can finally figure out what is the combination of actions that will lead to this heuristic system to break. But that is a separate issue from the alt issue, where alt is not really discoverable unless you read the documentation and see what the buttons are. Oh, one more thought. That I had that thought yesterday. It would be great. DF2RO, thank you for following. Welcome to the stream. I think what KiCad should have on the website is interactive key reference. So like an overlay for a keyboard, for at least a QWERTY keyboard, and depending on the modes, show what buttons are what. Because we do have, I think, button bindings, so you can look it up. Is it F1? No. There was some. No, question mark. Why is this slash suddenly? Oh. Anyways, it's there is a legend for the buttons for sure. But yeah, I do still think that there should be a way where it's like at least have a tooltip for this. Control F1. Ah, thank you. There we go. So there are hotkeys and commands. But yeah, a menu is already a good start. This is at least dynamically generated now. And you can see, oh, they are overlaid. Hotkey errors detected. Add microvia and routing options. Maybe it is colliding with some system hotkeys. But yeah, I still think there might be better ways. The Lethal Bit, thank you for your subscription. I really appreciate it. Thank you so much. Oh, sorry about that. I didn't do that on purpose. Yeah, so the Control F1 is actually also scene change. So that's why it is colliding. So yeah, sorry about that. Yeah. Let me pull this up and then switch the scene manually. I will show you then. Yeah, so there, Control F1 will pop up this button selection. All right, so let me catch up a little bit with the chat here really quick. So Wayne said he's working now with Seth at the KiCad company. So he's still working full time, as far as I understand. He's hired by essentially Linux Foundation. That's what I understood in the last update that he sent out. Yeah. Anyways, correct me if I'm wrong, but I think Wayne is still working full time on KiCad. They need contracts. Oh, yeah. Yes, so definitely hire them if you have, especially if you're a company that has some funds and you are doing PCB design and you might or might not be using KiCad. Definitely consider hiring Seth's company. Let me check what the name here is, because I don't. There should be a link somewhere. Community, maybe? I'm sure they added this to the... developers. I'm sure Drew will pull it up. KaiPro PCB. Thank you. Yeah, so this is KiCad Services Corporation. So they are a corp, and they essentially, you hire them with service contracts so that KiCad keeps working for you, and they can also develop custom plugins, custom features, custom stuff in general. So this is definitely, and if you look at the pricing, they are really well priced compared to other alternatives. These are really good prices. Especially if you compare it with anything else on the market. So they are either on par, like similar pricing, or better. So so in V6 we have you can import Altium designs. So this is a new feature that is in the nightlies. So now you can actually import. So now I'm seeing this, what Drew is saying here. So Beagleboard or contracted KiCad professional services, Seth and Wayne, and they and this was to add support probably to. It's Allegro and Cadence, Allegro Cadence. Okay. Still, we are getting more of those plugins to import different. So BeagleBone was using Cadence, Allegro Cadence. Wow. Okay, yeah, that's a great solution. Great. If you know what I mean. Yeah, that's awesome. So I'm glad that there is a converter now. Yeah, this was the problem with KiCad, especially when BeagleBone was the boards were made, it is way more time consuming to do high-speed design and high-density design in KiCad, or used to be. Now I don't see really a problem. For example, I did the HyperRAM stuff. You still need a script to do the multiple differential pair matching, but Greg Davil, he made a script, like a one-off, that I used, adapted, and it worked really well. It's like doing the multiple length matching was not a problem, but it would be nice to have it built into KiCad, obviously. So eventually these features will come, I'm sure. But yeah, we need more development time, more investment of developers that know what they're doing to join the project. So yeah, anyways, if you can donate your license fees for Eagle to KiCad instead, that's my recommendation. Go KiCad. Alrighty. Honov, thank you for following. And there was someone else that I just missed a second ago. David Number, thank you for following. Awesome. All right, so let's. I need a really short break for a second again, and then we will try to keep pushing on this layout here. I might do some of that offline because obviously I cannot focus properly. We are getting on tangents, although I enjoy it a lot. It's like, thank you guys for triggering my rants, I guess. I hope this is like I'm not pushing people away by just doing some ranting here. Anyways, all right, I'll be right back. Okie dokes. I'm back. Sorry, guys. Yeah. Linux Foundation. Thank you for the link. Yeah, the CERN money is tied to future development milestones. Yes. So yeah, I probably this year's contribution will go through Linux Foundation instead of through CERN. Yeah. That makes sense. Unfortunately, I have to wait a little bit now because of the situation, and there were also taxes, and this is like an unknown situation now. So probably I will only be able to contribute as when we do the Glasgow campaign, which is getting closer and closer, but we need to finally launch it. So, but yeah, definitely I will be doing that. And I encourage everyone to also follow Drew's link. And I will put it, if you watch this later as a recording, I will definitely include the links to the different donation sites and the corporation, the KaiPro corporation in the description below. So. Oh. Yeah, they're trying to be transparent. I have seen some people complaining about Linux Foundation, about probably because big corporations are giving them money too, and people are concerned that the corporations are still steering where the open source software goes. But yeah, otherwise we are back to using closed source software. So I don't know. The world is not so simple, I would say. So just I find in KiCad's case, it's end user software essentially, and giving money to Linux Foundation so that they can yeah, it's still a good thing. I agree, Drew. But it is always a balancing act, and nothing in life is so clear cut if it's good or bad. It is what you do with it. And so I think having the money go through Linux Foundation into KiCad so that this gets better instead of just transparently giving it to one of the bigger other vendors of EDA software that is completely closed source, and you cannot edit it, and you can't, and you have to like politely ask them to give you a free license for your university, instead of just, oh, I just download it for my university course and just keep going. This is the real openness for me. It's the ability for students and universities and teachers, professors to just directly access it without being on the whim of the big corporation if they give them a free license. And they have an incentive as a corporation to give a license to a company and to a university. This way, the students will buy their software later. It is like, what is the morality about that? It's like, oh, you are just bribing the students so that they use the proprietary software later. So this is not everything so clean and clear cut at the end. So yeah. So if we can measure, so there's a question if we can measure resistances within KiCad. I'm not sure. There is a PSpice support in KiCad in general, but I'm not using it very much myself. So yeah, same thing with mechanical design and SolidWorks. FreeCAD is getting better. It's still nowhere near to the level where KiCad is, in my opinion. So I tried to use this or I did use it to auto-generate footprints or 3D models for KiCad. Oh yeah, thank you, Drew, for the links. I appreciate it. And so I have the feeling KiCad, at least the developers here, they understand less is more. So they do, for example, they added the new rendering engine and editing features, the OpenGL stuff, and with the plan of retiring the old rendering system. In FreeCAD, I still somewhat have the feeling that they like to add new editing frameworks and keep the old ones around, which is for any use, like for me as a new user, really confusing. Instead of having a good set of editing frameworks that work well and focus on those, they spread very thinly the developer effort between multiple frameworks, including very old ones and outdated ones, and they keep replacing them too. I don't know, FreeCAD is still a little bit confusing to me. But that said, I am not a mechanical engineer, so take that with a big grain of salt, like with a good cup of salt. You should take a look at FreeCAD. And I'm sure I see it being improved for sure. And the scripting system with Python is really nice. So we can auto-generate 3D models for KiCad, for example, which is really neat. And that only half a year ago was barely working and really broken. And now I installed it, and within a few minutes it worked. There was no problem. So the auto-generation stuff of the 3D models, that works great now. So there's that. Let's hope that there's more of these user tools that will become better. FreeCAD is good. It's more the dodgy practices. You mean of FreeCAD, the dodgy search? That would be surprising. Anul does, yeah. Follow Anul. He does do streaming. Oh, SolidWorks. Oh yeah. But the same practices are being applied to Altium. like 100%. It's, or Eagle for that matter, now that it is owned by yeah, the same guys as do SolidWorks. So it's the practices that these companies do to basically gobble up the industry and gobble up students while they're young are, yeah, they make me angry because I want the freedom of like being able to use tools whichever I want and just learn this stuff. Anyways, let's stop with this. Let's do something upbeat, not the negativity. That's not bringing us anywhere. All right. Here on my desk, yeah, it's it's a ThinkPad W530 that I use for streaming. But as in my daily driver and travel laptop, I actually use an X1 Carbon laptop, and I also have a desktop machine for normal daily stuff. But for streaming, I use the ThinkPad W530. For now, at least, especially for synthesizing FPGA stuff, which I do quite a lot too. This machine is a little bit underpowered by now, so I would love to eventually slowly switch or like invest into a dedicated streaming desktop machine or like a small machine that has enough processing power to make synthesis. And so synthesis is mostly single core computing, so I need something with pretty good single core computing power. So yeah, if you if you want to help me to reach that goal, then Patreon is a good way of helping out. It definitely helps, and I'm investing that stuff into making these streams and get into the gear. So yeah, shameless plug here. As well as the subscriptions on Twitch. Although there's more money actually going into helping if you do the Patreon instead of Twitch. So Twitch takes 50% of the payments that people make, which is a little bit of a bummer. But whichever helps, whichever works, and whichever works better for you, that's really appreciated. Thank you so much. All right. Yeah. It's, you can squeeze out some more power by using more lean distributions. It's like, yeah. All right. So let's go back to the core topic of the stream. In theory, somehow we ended up just on the pure rant realm, which was fun though. Thank you very much. Okay, so yeah, so we were here and I was complaining about what I did. I moved the footprint on top of that trace, and that's why I got this DRC error. Yeah, let's clean this up. There we go. So a little bit cleanup. So, yeah, I still should probably move these guys away. I might want to make more space. So that's the interesting part here. Let's see how much space we need for the oscillator. Then we can move these resistors out of the way a little bit more. And then see, this will basically pull up all these vias further up. And yeah, so there is a cascade of constraints that we can relax a little bit. But the flash SS, so this is the question. Essentially, I could put this jumper on top of the board because there's not much components around here. The main concern with jumpers like this, for user jumperable jumpers, is to when a user is doing soldering on this, that they don't knock off some components all around it, and that they are not in the way. But maybe in this particular case, because there's so much open space here, having that jumper on top wouldn't be too hurtful. So maybe we should consider doing that. Do you need a license to make an x86 motherboard? I don't think so, no. Oh yeah, Mike confirms that. You mean the x86 ISA is dying? No, I don't think this will ever die. Well, not in the foreseeable future. Especially not for desktop CPUs. I do agree with Linus Torvalds here. I think it is completely irrelevant for desktop computing what ISA you are using. It is more about the ISA is only an abstraction layer, essentially. If you see the new architectures from AMD that they came up with, whatever the new one was, they improved significantly in performance and CPU per watt. Yeah, Zen 3. Zen 3 is about to be released, yeah. Or maybe Zen 2 was already there anyways. So the ISA on desktop, you have used compilers. This is all abstracted away under like bajillion layers of abstraction. So it is not really relevant as long as you get the performance you want. And there's so much dependency and legacy code and graveyards of techno stuff that relies on this. I don't think this is going anywhere anytime soon. In specific applications like server applications, there might be some ISA change because you can make things a little bit more optimized, but you have full control of the whole ecosystem. And RISC-V will gain ground, especially in embedded, 100%. And especially if it comes to, and it will definitely gain compared to ARM. Actually, it will make a big chunk bite out of ARM sales because of the licensing costs that are associated with ARM cores. RISC-V is more flexible. It doesn't require licensing fees. And I feel especially the Chinese market will be making a lot of RISC-V stuff in the coming future. We already see that. We also see companies like hard disk manufacturers that have complete control. They are completely getting rid of their well, I think I will work a little bit offline on the design. Yeah, Sylvain, I promise I will try to do some more work on this very soon. Anyways, so yeah, and the software for RISC-V is getting better. I think RISC-V will be quite a big disruptor. It already is. Consider like hard drives being, and yeah. Anyways, let's get back to it. I will try to ignore the distractions for a little bit. Alrighty. So should we put this guy on? So Sylvain, what do you say? Should we put this jumper on top of the board or not? You make the call. Let's do it interactive. And we should also decide what to do with the RGB LED. Can I make enough space here? I think I can. So we can move this one out of the way. We don't need this for now, and let's move this one too. And I think having this maybe aligned like this with the button would be nice. Okay, let's put it on top. Good. So that's the core. And this should be probably aligned like this, because this way we can do routing around this. The channeling seems to be about right there anyways. And then we can go to the bottom. So so let's see. And these jumpers, come on, this was selected here. We still need to decide what to do with these jumpers. What do I do? What do I do? What do I do? It might be good to have them here, here, but then I'm colliding with the logo. That's fine. I don't care. The logo is the last thing we can do. Same for VPP jumper. Oh yeah, you're right. This will very rarely be moved. Oh, if that's the case, if that's the case, we actually should switch them to 0402 jumpers. They are rarely being used, so we can save some space and just shove them in here into this whole mess of routing. I think that's a good idea. Let's do that. Where is the VP? This one. And also this shouldn't be a 30, it should be a 15, because this is a signal, this is not power. So let's do a 15 jumper. That's one. And then use this one, also make it a 15 VPP, because it's also signal. Somehow you have a lot of confidence into our wonderful experts. No, I think you're right. Yeah, this will be a fully fabricated. It's a 4-layer PCB, so there's no point in routing this out of copper. I don't have time for this. To be honest. Yeah, I know it is possible. So if you want someone who is crazy and amazing and does some amazing routing work, MG. MG is on Twitter. He does pretty amazing stuff with the CNC PCB router. I've seen the boards in person and I couldn't believe it. Like, you can do that on a CNC router. It's a Bantam tool thing. Oh my God. I changed my mind what you can do with CNC routing of PCBs after seeing what MG does. It's completely nuts. But he's very dedicated too. So yeah. Let's do this like that to make it nice and clean. And then we have this jumper. So we can do this either here, but are we blocking anything? I don't think we are. So let's do this. Oh no, there's no trace here. Good, good, good. Yeah, I'm sure someone from the peeps in the channel will give you a link in a minute. Don't worry. So let's just that can be routed. Oh, yeah. What's going on here? So oh yeah, right. So since not very recently, also KiCad is making collisions with those text things. So let's see, edit footprint. And I think it is colliding with the graphic here. Let's save this. Is it far enough now? Yep, now it's far enough. So the problem is that these jumpers, so that I can have these things disconnected, they are, so to have these two nets disconnected, I'm using a trick in KiCad where you have a trace inside the footprint drawn as a graphic. So that's there's so that it doesn't collide. Just remember to leave room for the X-Acto knife if they want to cut it. What? I missed something. Diamond Burr? The microscope? I don't know. I'm definitely... Oh, it's probably related to MG. He has a very interesting humor. It's like he made a video where he shows how to reflow stuff in the style of typical actions done in the context of drug abuse. Yeah, he has a very interesting humor. It's a good guy though. I met him in person. He is a good person. All right. Yeah, let's move this stuff out of the way while we are already at it. Oh, come on. I should probably delete this track again. This one, then we can move this like that. So that's nicely 3v3. Why is this turned around? 100 nano. What are you for? Oh, that's the clock 3v3. So this should actually go here, right? Like this. It's in the courtyard though. It's not a huge deal, it's annoying. Clock. Oh, so we should rotate this. This is not good. This is bad. I think this is more correct. Which way? So we want clock to be close. It's still going all across to the other side of the chip. It's a bit annoying, but it is what it is. Then we can move this guy to the other side, right. And then we can 3v3, yes, so let's move this, correct. Move this here, that's where you belong. Then we can move both of these. This is something I love about KiCad. You can actually use arrow keys on the keyboard to move stuff around. By the grid differences, it's really nice. And then this should fit around here. Perfection. Very nice. Then we don't need this. I think this was some bodging to try to get these connected. I can connect this to the 3v3 plane inside, and the clock should just pop out here, so that's nice. That works too. I'm probably missing some context here. Sorry, guys. So let's do this, and then this is not great. This is still colliding here. Let's do B. There we go, and then via like that, and then here, and then we can, the ground should connect itself if we refill. Perfect, perfect. Then we can have a full chunk of 3v3. Should we have them separate? Yeah, we probably should have them on separate vias connecting to the ground plane, to the power plane, I mean. Although we definitely need a via here. Unless we move these traces around. Do we need to? Yeah, we need to have one more trace for this signal here, for the IOB31B. This needs to go all around the footprints, because I have the feeling these guys will collide. But right. Why are we backwards here? That's backwards. So this should be on the top, and this should be on the bottom. VCCIO. Oh, this is VCCIO. Wait. There's a jumper for this. VCCIO1. Where is that jumper? That is not bueno. So this didn't rename that net. That's interesting. Oh, that's an example why we had issues. So, oh, I probably had a jumper connected here. Right, so let's see. This is what it is connecting. Right. So in the inner power plane, this goes all around here and goes around here to the VCCIO1, also connecting here. And then this is the jumper that connects 3.3 volts to the VCCIO stuff. Okay, so this jumper should be the other way around. Is that correct? Yes. Ah, there we go. I cannot select the jumper anymore. So yeah, we were playing around with the board for a little bit, and this disambiguation menu is not showing up anymore. Again. I'm really curious when that happens and what causes it to break. So yeah, we should snip this somehow. Current sensing might be a good reason to still split it. I just have those splitters also on the big board, so I kept them. We don't necessarily have to split them, but I like having more options for people to just modify the board. So it is nice to have these banks separated. It would be even better if we had jumpers for both banks separately, so instead of having them on the same voltage. Yeah, we already have the jumper. I think I still can fit it. So I will keep that jumper around. So this is how it should be. And yeah, now it auto-renamed the net. Wow, that was quick. That's awesome. I didn't realize it was doing that even if I just rotate apart. That's new. Before I had to do F8 or something so that it updated the nets of traces. That is very cool, though. I don't mind that. So there. So that's connected now. And we still need the VCCIO to be connected somewhere. We can't trace it. We could. Could we get it out of here? Yeah, it's probably safer to just get it out of here. Just like we did. Come on, can I do this? Not really. Nah, no. So we should, oh, it's on the bottom, I see. Like that. Let's do this. I think that's roughly what we had before. And now we can go like this and like this. Nice. Yeah. Someone could theoretically desolder the flash from there and run it on something different if they are programming it directly and need the IOs to be on a different voltage, or the current sensing to figure out what the power consumption of the bank is. That's not a bad idea to have. Yeah, especially if we can fit this jumper in here, and it seems we can. So let's rotate this one around. And this is wrong here. This should be connected. I think this one is, yeah, it's the regulator. There we go. Now it released it. And we use the 0.3 millimeter. There we go. 5 volts, 1.2 connected. iCEBreaker, iCEBreaker. Where are you going? Did I delete stuff? Or, oh, it was going to this plane here. Yeah, right. So if we enable the view of the plane, so there we go. So that's the plane. We still need to rename this as iCEBreaker. There. There we go. So now that is connected. So we have this floodplane, or the polygon, that connects the iCEBreaker around. So that's good. So that's cleaned up. And this is just plugging into that plane. Proteus, welcome. Welcome to the stream. Hello. Come on, why are you complaining? This should be connected here. Okay. This track, what net? NC name. Oh, it's because of the 1.2 volts here. Wire on 1.2 volts. Who are you? Yeah, this is... I'm glad I used the normally connected jumpers now. Oh, it's not 1.2 volts. VCC PLL. So we should have it on iCEBreaker. Should this be iCEBreaker instead of 1.2 volts? Probably, yeah. I think it is. The PLL should be also on the core voltage power supply chain instead of. And this should be a ferrite, I guess, instead of a 100 ohm resistor, to make it to be fair. This is also copied from some dev board from Lattice, I think. Yeah, so let's just do that. Come on. There. Now F8, update PCB, close. What happened? Oh, I connected it to ground? That is silly. What happened here? Who followed? The Lazy Fish. Thank you for your follow. I appreciate it. Welcome to the stream. Yeah, that was stupid. I connected it to ground. I'm a dumbass. Let's do this correctly. That's better. There we go, much better. So that's the resistors, that's the capacitor to decouple the stuff. Yeah, iCEBreaker, and I should reroute the... What? No, I don't think we need that thick traces here. I think we are totally fine doing... Oh, that's the iCEBreaker IO there, like this. Yeah, there we go. So that's connected again. Cleaned up. iCEBreaker IO 2, it's 3.3 volts. That's good too. And then we can connect this. And then the 3.3 volts here. So that's, I think I have to make more space, and I probably should put the connection here for 3.3 volts. I'm a little bit afraid that this, if I don't use a separate via for the 3.3 volts here, that there will be some weird bouncing or whatever. Oh, what is this garbage here? Yeah. That said, I just realized that we are already 2.5 hours into the stream, which means we are, yeah, it's 2:17, so we are a little bit over the allocated stream time. I am really sorry that we didn't get as far in routing as I hoped for, but I hope the rants were actually worth it. And I really apologize to Sylvain that is really hoping for this board to get finished. I think what I will do is schedule another stream very soon. It's like I have to see if I can schedule something for tomorrow. Then we can keep going on this and get some more work done. Yeah, it's after midnight in Europe, probably. Disable chat? No. This is part of the fun here. This is a stream after all. I would just sit down
and do it on my own time if this was not just also the enjoyment part. So I like doing these streams. I hope everyone is getting something out of it, especially. Oh, there's another jumper. Let's rotate that one too. Yeah, they are all a little bit wonky here. Let's see if that works. This shouldn't be 5 volts, should it? There's some other pad that is on the 5-volt rail. The via seems to be the only one that is being stubborn, huh? Yeah. Net J38. J38, pad 1. Let's see. Net assigned to you 1, pad 5, and pad 3. What? No. Track and via properties? What are you talking about? This will change the net assigned to U1 pad 5 and R3 pad 1. Okay. All right. What are you talking about? So this is the disconnection jumper. Oh, you have to stay up really late, huh? What time do they have the stream? Especially if you were, I think, last week on Adafruit's show and tell, which is like at 4 p.m. Oh, 4 p.m. Eastern time, which is, yeah, oh, it's really late. Oh yeah, okay. It's still really late. Are you sleeping at all? I hope you're sleeping. Sleep is very important. Just FYI, it's like don't. Sleep is more important than anything. Otherwise, productivity is terrible and everyone is sad. And your health also takes a hit, which is even sadder. So yeah, I hope you're getting some sleep, man. This is weird. Okay, so what's going on with that via? Yeah. I think what I did is actually create a via like this, and that's what it was complaining about. Page down. J38. That should be working. What the hell? Is that a different... Can I get just the text off? Text back. No. Let's do back silk screen off. There we go. Oh, that's what's blocking it. There we go. Okay, now I see it. Oh, CS Lectures. Thank you for the raid. I think that's the first raid to my channel. Thank you so much. Welcome, everyone. Oh, thank you so much. Yeah, welcome, everyone. So actually, we are like almost winding down, but we are designing a PCB to make a nice FPGA development board. So this is a small FPGA development board in the format of, let's say, the Teensy Arduino board and similar. So we have several things on here. This is a very small 5000 lookup table FPGA and a USB connector. And yeah, you can see it here on the desktop. So these are the tiny boards that this is derived from. So iCEBreaker FPGA is a board that I make, and it has an FTDI programmer and FPGA on it, as well as Flash. And we are making a smaller version of this that is of this size. So this is what we are working on. We are making some changes. So yeah, I'm doing I made a few streams already in the last few days about the layout of the board, and now we are doing routing and trying to figure out the puzzle how to get everything connected and everything cleaned up after I made changes to the schematic. So if you look here, this is the schematic of the board. We have USB, we have an FPGA, we have RGB LEDs, we have a clock that clocks the FPGA, we have 2 power supplies, and we have a flash chip that contains the configuration for the FPGA, and a small RAM chip that is optionally can be populated, and a little bit button. And so yeah, you can plug it into a breadboard and do some digital design. So you can design digital circuits, as well as you can load a full CPU into it. So you can configure the FPGA to be a microcontroller, for example, with custom hardware attached to it. So it is essentially a 1 layer below, like from if you were looking at an ISO layer, for example, for networking, you would be going down into the physical layer. And this is essentially even a lower layer where you can configure the logic to become a CPU that you would then program. So considering you are computer science students, you are programming stuff, so you are programming a CPU that the FPGA can emulate. So yeah. In FPGA's world, so you can have hard IP, that's how it is called when you have a specific purpose blocks inside the FPGA. In general, FPGAs are completely flexible. And even the USB interface that is on the small boards, at least, is directly connected to GPIO pins, so general purpose IO pins of the FPGA. So every pin essentially is general purpose, and you can configure it to become the protocol or the block that you want to be. So it is inherently more flexible than a CPU that has dedicated blocks for certain protocols that you can maybe choose between 1 or 2 different blocks. Here you design the blocks themselves, so each pin of it's like, I'm a little bit oversimplifying here because there are dedicated pins, for example, for differential pair signaling on more complex FPGAs especially. But in this case, it is a fairly simple one, and we have an SPI hard block in here, which is more useful for simple stuff. If you want something high speed, you would design your own anyways. Then you have general purpose IO, as well as 3 pins that are dedicated for driving LEDs. So they are just pull down pins. So yeah. USB is the main interface as an in-out for this board. Yeah, so the reason for that is on the bigger board, we have an FTDI chip. FTDI is a USB to protocol converter, and the protocol can be either UART, so serial, or SPI, or parallel bus, or JTAG. And so, but this is, again, this FTDI chip is fixed for certain things. You can bit bang data, but this is not very fast over USB. It is also specific to certain purposes. We are making this small board for use with, for example, CircuitPython. And CircuitPython requires a more complex USB interface, which emulates a hard disk where you can drop in binaries into. So we are working on this board to implement the USB stack inside the FPGA itself. So that's the goal of the project here. So yeah, anyways, welcome everyone. I was actually about to slowly wind down this stream, but let's keep going for a little bit longer. Forklifting, thank you so much for your follow. Welcome to the stream. Yeah, thank you. I'm glad you like it. So yeah, I am currently trying to solve the puzzle of how to route this board and make all the electrical connections. And I just realized Field Effect, thank you so much for the follow. Welcome. Yeah, so I'm looking at what these pins are, and this seems to be the 5 volts. Yeah, so we should have this connected to 5 volts. So this should be connected to here. Just continuing. Yeah. Yeah, good point. Just glue me to the chair by sending additional raids into the channel so that I cannot just stop the stream arbitrarily. It's not that simple. So yeah, if you want a well-designed logic for a specific protocol, you want to usually design something more special for it. I'm sure there are generators and are more arbitrary for different protocols. But yeah, at the moment, most of the stuff that I see is specifically designed for a certain protocol, and it's easy enough in a sense. You do have some generators for specific protocols, for example, PCIe, if you want, or DRAM interfaces. So you have machines that generate the Verilog or the design language that then is synthesized. So you are not designing directly the logic. And also that is also not very true, because synthesis tools like Yosys, which we are using here, this is the open source, this is dedicated for open source tools. So it's meant to decrease the barrier, especially for universities and schools, so that they don't have to beg for free licenses from FPGA companies. And so Lattice chips are supported by open source FPGA design tools. And they work well enough to be used in production, actually, for products too. So by now. And so the synthesis tools, which is Yosys one of them, they also take what you want, and it's inferring what it should do in the FPGA to implement what you ask it to do. So it's not like you're oh yeah, I think I heard of that tool that can do FPGA communication. Oh yeah, no problem. You can link to stuff. It's relevant to the stream, so yeah, don't worry about it. Thank you for the link. I'm sure it is interesting to some people here. Okay, so let's get back to it. So we have this. This is a 10K resistor, which is a pull-up for the enable, which should be just connected to 5 volts, which is on this side, so that we can enable the power here. So we shouldn't be connecting it to the USB interface. So that's another bug that I had in the PCB design regarding the jumpers. Great. So we just changed those to not be just normal open jumpers, and we just connected the nets together. So this is much cleaner. And we found another bug in the design. And this should be probably 5 volts from the USB connector, shouldn't it? In the in this array. Yes, it should, because then we can still use USB, and this should be referenced to its own 5 volts. Okay, so let's change that. First of all, we need to give this a proper name here. What is it? USB, VCC, what is it called? VBus. Something like that. UVBus, let's call it UVBus. Yeah, this is where Sylvain is laughing a little bit, where he's like, Yeah, no, that's the point I'm trying to make here. You might be using it. Yeah, no, positive bias they should have, but I think the ESD bias should be connected to the USB connector VCC and not to the board VCC. Don't you think? I think this shouldn't be 5 volts, it should be UV bus. Oh, really? Why is that? You mean, so this should be 5 volts as is. Interesting. I'm now a little bit. Yeah, I understand that. So, okay. So I agree with you that they should have a positive bias. The question is, should the reference be 5 volts or should it be UV bus? That's what I'm not exactly sure about yet. Because I would think because those signals are coming from the USB connector, they should be biased against 5 volts, although we are protecting the FPGA, right? So maybe it should be the internal 5 volt reference of the FPGA instead. So that's what I'm not 100% sure about here. And I assume you are saying I should leave this 5 volts and not connect it to UV bus. So I will leave that for the moment and assume that's what you mean. And let's try to connect it. Oh, okay. Interesting. CS lectures, you should definitely join our Discord. There's a lot of FPGA people in there. And you might find some interesting. I definitely would like to see you share your work with us on that server. It would be nice to see more people on there. So now I think we should, this should be 5 volts, so we might be able to connect it just internally, right? Like this, and we should actually have it connected on this layer, like that. How about this? That should do it. Forklifting, yeah, there's a lot of good projects referenced in the forum on Teensy or the tiny FPGA. So this is actually a tiny FPGA that I have here. So the board that we are working on is also inspired by Luke's designs. Luke is a great guy. So congratulations to your tiny FPGA. Yeah, definitely blink an LED. That's the first thing to do. That's the hello world of FPGAs. Okay, so now I think we have this fairly cleaned up. We have a little bit of railway here, splitters, but that should be fine. So that's done. I still have to figure out the Lost Huskies. Welcome to this stream. Thank you for your follow. Also, you can check out the examples that are on the iCEBreaker GitHub repository. These should work on the tiny FPGA with minor changes. So if you're interested, there are some additional examples there. Yeah, CS Lectures, thank you for your follow. Yeah, so let's keep going. So the RGB LED is still a thorn in my side. USB detach. We could actually do the detach from here and move this here. I want to keep the symmetry here with the red and green LEDs. Yeah, I do have the feeling I want to put the RGB LED here, closer to the RGB pins, even, and get the jumpers on the back there. Still have to drill through 3 times for this to be connected. Ground 1.2 volts. The alternative would be to have this on top, on the bottom, rotate this, and then have ground from the top instead of the bottom. Then I can clear up. I don't need the ground connection here then. I think that's a cleaner design. So let's do this. Rotate it around and then connect it here. Oh, we can just keep it as is and just do the zigzag. That's fine. Like that. And then this should connect the ground. There we go. Okay, that's cool. Let's see what we can do with the LED-G. Okay, let's move the RGB LED first. .3 volts. I wish, in this case, I almost wish the 3.3 volts were on the right, so that I can have the shorter trace to there. Although, that should work, shouldn't it? This will be fun, because the routing will be pretty hard here. It's really dense in here. Oh, and we have a collision again here. We have to get rid of that. If I didn't do the jumpers, these jumpers, to disconnect the RGB LED if I don't need it, then things would be much easier, for sure. Yeah, I do think I have to do it here, because then I have plenty of space for the jumpers. Yeah, I think I have to move this still down here, so that I open up more routing space for myself. The 3.3 volts could be actually here, and then USB detach could be on the other side, even though it breaks the nice symmetry in this area here. Okay. I'm trying to squeeze it too hard. So let's put it in the center of the... another thought I had, which would be really cool, if these buttons actually had a cavity on the inside and a transparent cap, I could put the RGB LED on the inside of the button. That would be really nice, to have an RGB button takt switch on this board instead of having a separate LED. Just a thought. So yeah, there we go. So I have a little bit more space. And now let's move those jumpers, because I do think this is much more likely that someone will want to separate them. This is one somewhere here. Yeah, Should be probably here, right? Green. Blue. And then, oh, this is wrong. Like this. Like that. And then the third one goes on the bottom, correct? Come on. And then we can put this one here. That's the red. Okay. Something along those lines. iCEBreaker Mega. Yeah, so the iCEBreaker full size, I want to eventually start populating the LEDs, and this definitely will be pre-populated on the small bugger, on the Bitsy. That's why I'm adding the jumpers. If it was self-populated by the user, I wouldn't add the jumpers. But because we are populating it, I want to give an easy way of disconnecting the RGB LED without having to desolder the really tiny part. Because consider this is an 0402. This is about twice the size of an 0402. So it is really small RGB LED. And so soldering and desoldering it doesn't seem like a good thing to do. And for the big iCEBreaker, I was thinking of starting to populate the RGB LED and also adding the jumpers to give a little bit more stuff to play with from the get-go. So that's the idea there. Yeah, so now we have at least everything on the board again, and we cleaned up the power supply stuff a little bit. So that's it. Let's finish routing this. This shouldn't be so thick. I don't think we need to be. This is not really high power stuff here. And like this. This is not great. This is an acid trap. You don't really want to have that if you are connecting things together. So it is better to have a T in situations like this than having a sharp corner like this for etching purposes. So we rather do something like that, I think. Yeah, let's do this. This is still a trap here, but this is definitely better than it was just a second ago. So this is just a pull-up. This is a capacitor, decoupling capacitor, so that looks fine. I still have to decide what to do with the 3.3 volts here. And I probably need to move the signals a little bit out of the way. And this needs also power plane connection. But just to see how things look, so this is, So the idea here that we had is we will just trace this into the pads and then either break it out on the bottom or the top. So no, just drag. I need to move this guy out of the way here. Drag anyway. Come on. Move. So we can have these straight. Like that. That's one. This goes to the signal. So this is interesting because this goes down here and then goes up there. So maybe, just maybe, we need to rotate the whole set of both of the flash and RAM chips all around to match this pinout. Although this pinout is pretty arbitrary itself. I don't exactly remember why I had it the way it was, to be honest. I think it is the same, similar to what I have on the big icebreaker. I don't know. I can figure it out next time. Because my brain starts to be mushy already. Like this. And then on the bottom, it would go like this, and then connect to the top. So that's the technique we were thinking about. Something along these lines here, there, and then here. This is better than having to flip it all around, I think. Now we are already out of space here. .commie, thank you for your follow. Yeah, so we will have to move this stuff around like this, something along these lines. Come on, come on, come on. There we go. Something like that. Huh. And now already the top bottom solution thing is not working anymore because these pins are already too early. So I will have to, what? Go around somehow? Oh my goodness. Okay, so this is where the puzzle part becomes interesting. Because this is the fun thing. These bottom two have to go to the top here. Oh, I know what I have to do. I have to swap these to the top in this area first and then do the reconnection here. So this will be a little bit of a routing fun. Yeah, I have a feeling I know what I have to do, roughly. So let's see what happened here. Rosfimus, thank you for your follow. Welcome to the stream. Anyways, I think we did quite a lot today, and this is a longer stream than usual. And I think we will stop where we are for now. I will commit this as is to GitHub. So if you want to check it out, so first of all, I will push it to the GitHub. I will announce it on our Discord. It is on a regular basis being posted here in yeah, Jordy. Thanks. Yeah, you are right. I definitely, this is totally solvable. Yeah, I think I know what you're talking about. We can look at this. I think we should do that in the next stream though, because I'm way overdue to stop actually. But yeah, as I said, join our Discord. I will announce when I push this stuff. If you want to take a look at this, I will have it on my GitHub or the iCEBreaker FPGA. There's this repository. What's happening here? So the changes will be here. I probably should update the readmes, but yeah, in the hardware there is the Bitsy version 0.3a. This is what we are working on. And so I will definitely, and I think this version will become 1.0 after we make sure this works fine. I might actually skip directly from 0.3 to 1.0 for this board and call it good, and then do only the A, B, C, D, E revision changing, which shouldn't be signal incompatible or move too much things. Yeah, that should be it. Yeah, let's go to full face. Yeah, thank you very much for being here, and I hope you all are doing well. I hope this was somewhat interesting, and we ended up doing more ranting than actually doing work, and I'm sorry about that. I will try to be a little bit more focused next time, even though the rant was a lot of fun. I enjoy I enjoy sharing my strong opinions, I guess. I hope you are still here for that too. That's what streams are specific about. It's not really 100% just pure work or pure tutorial stuff. And yeah, I hope you got something out of this, and I'm looking forward to seeing you in the next stream. I definitely encourage you to, if you like what I'm doing here, to support us here. It's all very small operation, and the streams are definitely taking some resources, and I hope you can, if you can support it on our Patreon, and maybe subscribe to the channel. That's really appreciated. Check out our products in 1BitSquared. So the FPGA boards that you're seeing here, they are available there. The PMODs are available there, and definitely the people that decide to purchase our products make these streams possible. So I really appreciate that. I definitely want to say thank you to the Patreons that are every month pitching in to help with the expenses of running these streams, and those are Edward Brodin, Jerzy Hacker, Jordi Parky Rodriguez, Sid Price, Kelly and Tom Keddy. We also got new ones, Drew Fustini is now also a shout-out tier backer, so thank you very much for that. And yeah, everyone who is here, I really appreciate you. Thank you for taking the time. Yeah, PDP7 is Drew. Thank you so much. Yeah, and this is really all a community effort. It's all open source, and we are all sharing stuff here that we work on. And if you don't feel bad if you don't have money to donate to this. This is why we are doing this, to share knowledge and know-how and spread information and teach people. Just like Boltport, for example, does, which I'm wearing the t-shirt of today. There's a lot of really great people in the FPGA community, and I really appreciate it. You are all lovely and beautiful people. Thank you so much. And I will see you hopefully very soon. I will definitely try to schedule another stream for really soonish, because we have more work to do, and we are getting close to actually finishing this board so that Sylvain can order the boards for himself. Yeah, so as per usual, if you have been, thank you for watching. Bye!